Okay, we're looking at a population of 6,000 people. We've drawn a sample of size 12. Simple random sample. Does that mean with replacement or without replacement? Without replacement. Simple random sample is without replacement. Okay? If we have a box that has 6,000 weights in it, is that a 0, 1 box? No, right? Weights can be anything non-negative, right? Can't have negative weights, but other than that, we don't know a whole lot. All right, so here is a sample of 12 weights drawn from that box. And what we want to do is estimate the average weight of the population and estimate the error of our estimate. Okay, so our estimate of the average weight of the population would be the sample mean, right? This is our sample. The sample mean is an unbiased estimate of the population mean. So adding these 12 numbers together and dividing by 12 is the sample mean. And if we do that, the answer is 128.447. So that's our estimate. But we know that our estimate is not likely to be exactly right. It's going to be off by something. Question? Yep. Okay. All right. So it might be too big. It might be too small. We don't know which in any particular case unless we knew the 6,000 numbers that were in the box, right? But what's the sort of give or take number that ought to go with this estimate of 126.447? Typically, how far off would the sample mean of a random sample of size 12 from these 6,000 numbers be from the mean of the 6,000 numbers? So we can use these 12 numbers to try to get a handle on the SD of the box. The amount by which our estimate is likely to be off is a standard error. The standard error is going to be F times the standard deviation of the box over the square root of n. We don't know the SD of the box, but we can estimate it by the SD of the sample. Not going to be a perfect estimate, and in fact, for a sample of size 12, it's probably not even going to be a very good estimate, but it's something we can do nonetheless. So because this is not a 0, 1 box, we're going to tend to use the sample standard deviation S rather than the standard deviation of the sample S star to estimate the SD of the box. Okay? So what would we do? We need to find the sample standard deviation, which involves doing this calculation that I've covered up. We need to take the sum of the squares of the residuals between the data and the sample mean. Divide that by the sample size minus 1, 11, and then take the square root of the result. So these are the data again. From each datum, I need to subtract 126.447 and square the result. Okay, so this is 118.72 minus 126.447 quantity squared. Okay, so we'd add up these 12 numbers and divide by 11 and then take the square root, and that would be our estimate of the SE of the sample mean. Oh, sorry, we multiply by the finite population correction, which is going to be very, very, very close to 1 because 12 is only a tiny fraction of 6,000. The sample size is only a tiny fraction of the population size. So the finite population correction is very, very close to 1.